Doctor, we're registering the data where?
We have the timer 0 low and timer 0 high, the two registers that we have seen previously.
Oh, the same, okay.
The same, okay? So this 0, 0 is the value of timer 0 low, and this part is the value of timer 0 high. Okay? So the pulses are fed from the timer 0 clock inputs, which is the pin number RA4. And the counts are stored in the two registers, timer 0 low and timer 0 high. So this is our pin. So if you have a sensor, for example, you have to connect this sensor to the pin number RA4. So here we have external clock source. Okay, so this is our timer 0 control. You have just to select this the timer 0 clock source. You have to make it external. Okay. So we have here example, find the value of timer 0 control. If you want to program timer 0 in 8-bit mode, counter without prescale. So it is the value of timer 0 control here. So we have counter, 8-bit mode without prescale. So first of all, this bit is 0 or 1 before starting.
0.
0. So while you are making the configuration, this bit is 0. Timer 0, 8-bit, 0 or 1?
1.
Why 1? Because we need 8-bit mode. So we need
8.
counter. 8-bit mode, no prescaler. So 8-bit mode, here this bit should be 1. So timer 0, 8-bit should be 1 to have 8-bit mode. Now timer 0 clock source, external or internal?
External.
External. Why external? Because we need timer. And the timer 0 edge, so it doesn't matter. You can use any edge. Okay, we can make it 0. And the prescaler, no prescaler. Yani you have to bypass the prescaler. Yani the PSA should be 1 or 0.
1.
1. That's it. So if we don't have prescaler, the values of this bit doesn't matter. So what is important here is just timer 0, 8, 1, the timer 0 clock source 1, and the PSA 1. So this is the value of timer 0 control. Okay, so the values here doesn't matter, this value doesn't matter. So we can select them as 0. So the value of timer 0 control is 0x68. Let's see now program. Assuming that clock pulses are fed into timer 0 clock input, which is the pin RA4. Write a program for counter 0 in 8-bit mode that count the pulses and display them on 4-bit. So here we are using 8-bit mode. 8-bit mode, and you are reading the value from timer 0 clock. So here our task is just reading the data from timer 0 low to 4-bit. So here our main task is just continuously moving the data. So we can use move FF timer 0 low, comma, port B. So here we are supposing that, for example, LEDs are connected to port B. So we need to display the number of counts or the number of pulses that we have. Okay. So first of all, we have to make the initialization of the timer. So we have to give the value of timer 0 control. We have seen that it is 0x68. So port B is output, so clear F, this B. So we don't have timer mode. So if you have counter mode, generally we start the timer by the value 0. So move LW 0, move WF, timer 0 low. We have to clear the flag. And now we have done with the configuration, we can start the timer. Bit set file, timer 0 control, timer 0. So here our main task is moving the data. We have move FF from timer 0 low till 40. So we can make it continuously. So here we are just checking the flag. If the flag is 1, we have to stop the timer and repeat. Okay? But even if you ignore this line, it will be always working. Okay? So we can make a program, for example, if the number of students is greater than 255, we can display an error message, or we can do something like this. So in that case, we can check the flag. But if you are supposing that the number of students is less than the maximum value, which is 255, we can ignore this line. Clear?
No, Doctor, what I didn't say when we are we incrementing the law?
We are not incrementing. When there is a pulse,
Yes.
the timer 0 low will be incremented. So we start with 0, 0. At the first pulse, it will be 0, 1. We have to send this 0, 1 to port B. Okay. Then if there is another pulse, it will be 0, 2. We have just to send continuously the value. So our main task is just moving the data from timer 0 low to port B, because we are displaying the number of counts. That's it.
Incrementing is done automatically, right? Like
Automatically,
inside.
yes. So here we have external, okay? So we have a sensor, and the sensor will generate these pulses.
Okay.
Okay, I will give you just a small introduction to timer 1. Okay, so timer 1 is 16-bit timer. It doesn't work as 8-bit timer, okay? It is accessed as low byte, which is timer 1 low, and high byte, timer 1 high, okay? So the timer 1, it has a control register, which is timer 1 control. It is an 8-bit register. The timer 1 has a flag, which is timer 1 IF. So this timer 1 IF, it will be 1 if there is an overflow from FF till 0. So the timer 1 IF is one flag of the PIR1 register. Now, the first difference between timer 1 and timer 0 is that timer 0 is 16-bit mode. The second difference is that timer 1, it has only these 3 scalars. It can be 1 or 2 or 4 or 8. So what is important for timer 1? So timer 1 has 2 options when using external clock. So we can use it as a counter if we are feeding the clock source into the timer 1 clock input, or we can also add an additional crystal. So we can have a crystal connected to timer 1. So we can have our peak microcontroller with the crystal frequency, with the crystal connected to the pin OSC1. Oscillator input, oscillator output. Okay, let's make it OSC2. And we can have here another crystal for timer 1. So here we have timer 1 oscillator input, we have timer 1 oscillator output. So here we have the pin 13, 14, and here we have the pins. We have to return back. Okay, so for the main oscillator, we have the pin 13 and 14, and for timer 1, we have the pin 15 and 16. Why do we need to add another crystal? So if our application is, for example, real-time clock, to generate a real-time clock, we need an exact precise crystal. We need precise frequency. So if you need precise frequency, we can have in the market crystal frequency dedicated for the for this application for real-time clock. Okay, so in that case we have two oscillator, we have two crystals, one for the peak microcontroller and one for the timer one. So this is the advantage of timer one. If your application needs precise time, you have to use timer one, and you have to use an external oscillator for timer one. Okay.
Yes, doctor. So for the oscillator, we need 2 pins for each oscillator.
Now, if you want to use timer one as a counter, like timer zero, in that case, you have to use this bit, which is timer one oscillator input, the pin number 16. If you want to connect the crystal, you have to use the 2 pins 15 and 16. We have 2 options for the external clock source. Is it clear?
So the crystal takes 2 pins, not only one.
Yes, the crystal needs 2 pins.
Okay.
The rest will be the same. Okay, you can check this at home. So this is timer one control. So here for timer one, for the P scaler, we have 0, 0, 0, 1, 1, 0, and 1, 1. 3 scaler can be 1 or 2 or 4 or 8. There is no bit, name it PSA. Okay. For the interrupt, you have the timer one IF, which is one of the 1 bit of the PIR1 register. Yeah, let's see an example now to summarize what we have seen. Let's see now how to program the timer with interrupts. Okay, so I have seen how to use the timer by using polling technique. Now let's see how to use the timer with interrupts. So the timer flag is raised when the timer rolls over. In polling technique, the timer one IF will be monitored. But if you want to use interrupt, in that case, when the timer 0 IF or timer 1 IF is raised, this will make the microcontroller jump to the address 8. And from the address 8, you have to redirect the peak microcontroller to the ISR that we need. Okay. So for the timer 0, you can see it is main source of interrupts. So in order to use timer 0, the global should be enabled and the timer 0 IE should be enabled. But if you want to use timer 1 or timer 2, in that case, in order to use timer 1, so the timer 1 IE should be 1, the peripheral should be 1, and the global should be 1. These are the registers of the timer. For timer 0, we have the timer 0 IF and the timer IT from the INTCON register. For timer 1, we have the flag in the PIR1 and the enable in the PIE1. Let's see an example. While the data is being transferred from port C to port D, we have to use timer 0 and timer 1 interrupt to generate square waves on pin RB1 and RB7. Okay, so here we have our peak. We are reading from port C and we are sending to port D. At the same time, we are generating square signal on B1 and we are generating another signal on B7. So here, how many parts do we need in our program?
6.
5, 6.
5 parts. So what is the main task? Main task is sending the data from port C till port D. And we have 2 ISR. We have one ISR for timer 0, for example, to generate this delay, and another ISR for timer 1 to generate this delay. So we have the part number 1. So the part number 1 is always, what is the part number 1, Shabab? So it is org 0, go to me.
Go to me.
What is the part number 2? We have to redirect the microcontroller to the ISR that we need. Okay, so this is the part number 2. The part number 3 will be the main. In the main, what do you have to do? Input output
see.
configuration. What else?
اللي هو interrupt configuration.
Interrupt configuration. What else?
والمين loop اللي هو
Other.
maintenance
قبل
task.
المين لوب.
Other
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 timer.
configuration.
The timers configuration. And then we have the main task. And the main task should be within loop.
loop.
And then the part number 4 will be timer 0, ISR. This is part number 4. And we have the part number 5, which is the timer 1, ISR. Is this clear?
Yes.
Okay, let's see the program. It is very simple. So for timer 0 or timer 1, how to generate this signal? If there is an interrupt, what do you have to do?
Check the flag.
So here we need B1 and B7. So if there is an interrupt of the timer, if the timer generates an interrupt, yani we reach the delay that we need. So the main task is just toggle the bit, B1 or B7, okay? And then we have to clear the flag, which is for timer 0, we have to clear timer 0 IF. And the last instruction is red flag. But if the flag is 1, what is the initial value? What is the value of timer 0 low and timer 0 high? It is 0, 0, 0, 0. For the next time, we don't like to start with 0, 0, 0, 0, but you have to start with the initial value. That's why here you have load the timer with the initial value. And if there is an interrupt, so this is the part number 4 and part number 5. For timer 0, if there is an interrupt of timer 0, we have to toggle B1, we have to clear the flag, and we have to give the initial value of timer 0 again, and we have red flag. For the part number 5, same thing. We have to toggle the bit B7, we have to clear the flag, timer 1 IF, we have to load the timer by its initial value, and we have red flag. So, is this clear?
Doctor, but it's just one part, the loading the timer. Why should
Yes, we have to give the initial value. So here they didn't give us anything, so we can select any value. Okay. We have the value of timer 0 low and the timer 0 high. Okay. So here we don't have any information. We can select any value. Okay. This is the program. This is the part number 1. What is the part number 1? Fork 0, go to main. واضح? Okay, and part number 2, so we can directly write the code, but here they used another location for checking the interrupts. Okay, so this is check interrupt. We can do it directly at the address state. So here we have to check 2 flags. So btSPICE keep clear the intcon register comma timer 0 IF. So if this flag is 1, we have go to or VRA timer 0 ISR. If not, if this flag is 0, there is skip. We have to check the timer 1 IF. So if it is 0, we have red flag, we return back to the main. If it is 1, we have go to timer 1 ISR. This is the part number 2. Is this clear? So we can do it directly at the address 8. So here at the address 8, they use it just go to check interrupts. And they use it another location, for example, org 400, we have go to check interrupts. So it is the same as putting this code at the address 8. Clear?
Yes.
Okay, so the part number 3 is the main. In the main, we have the input output configuration, interrupt configuration, and timer configuration. So let's start with the input output configuration. So B1 should be output, B7 should be output, 4D should be output, and 4C should be input. Then we see in the next slide the timer configuration. For the interrupt configuration, we have to enable the timer 0 IE. We have to enable the timer 1 IE. We have to enable the peripheral because timer 1 is peripheral, and we have to enable the global. So this is the interrupt configuration. Then we have done with the configuration. We can start timer 0 and start timer 1. Okay, so this is for the configuration, and the main task is just moving the data from port C to port D within a loop. So this is the input, output configuration. This is the interrupt configuration. This is the main task. And what is missing is just the timer 0 and timer 1 configuration. So for timer 0, what we have to do, we have to give the value of timer 0 control. We have to give the value of timer 0 high. We have to give the value of timer 0 low, and you have to clear the flag. So here we are using any values, okay, for timer 0 high and timer 0 low. Same thing for timer 1. We have to give the value of timer 1 control, the initial value of timer 0 high, the initial value of timer 0 low, and you have to clear the flag. So this part is the timers configuration. And you have done with the main. Is this clear? So we have to give the value of timer 0 control, the value of timer 0 high and timer 0 low. And then
This
you
is
have to
part
pick
4
the
and
flag.
5.
Okay?
This is part 4 and 5.
La, this is the main. This
Ah.
is this part, which is timer configuration. In the timer configuration, we have to give the value of timer 0 control, the value of timer 0 high and timer 0 low. And you have to clear the flag for both timer 1 or timer 0 and timer 1. We have done with the main. So now we can see the part number 4. So this is the part number 4, which is in that case timer 0 ISR. So we have to give the initial value of timer 0 high, the initial value of timer 0 low. So when there is an interrupt, what is the main task here? The main task is just toggle B1. So BTG port B, 1. We have done, so we have to clear the flag and we have to use rectify. So here instead of using rectify, they are using go to check interrupt, and in check interrupt you have rectify, but you can also use here rectify. Part number 5 is identical to the part number 4. We have just here to do it with timer 1. So move LWFF, move WF timer 1 high, move LWF2, move WF timer 1 low. Then our task here is just to toggle B7. Then you have to clear the timer 1 flag, and then you have rectify. And you have. Any question about the timer?
Doctor, for timer 1, you said there are 2 modes, right? Mode 1 and mode 2. Mode 2 was what?
For timer 1, we have 2 modes. We have a counter and we have timer. Okay, so we have internal clock source and we have internal clock source. For the internal clock source, you are using it just to generate time delay, like the example that we have seen here. Okay, so we are using internal clock source. For external clock source, you have 2 possibilities. We can use it to count external events, or we can use it to generate time delay, but by using an additional crystal. So we use just this generally if you have RTC, real-time clock. So for RTC
Using
to
crystal,
generate
what crystals we have?
real-time clock, we need to add another crystal. I will return back to the pin out to explain. Okay, so this is the pinout. So for the timer 0, what do we have? We have here just timer 0 clock input. So if you have external mode, you have to connect it here. Okay.
We have to connect crystal here.
No, for timer 0, we are talking about timer 0. Timer 0 in external bit, in external mode, you have a sensor. The sensor can be connected to RA4, which is timer 0 clock input. Is this clear?
So a sensor, not a crystal.
A sensor. Now for timer 1, if you have a sensor and you want to count the number of students, for example, that get in the room, you have to connect your sensor here to timer 0 to timer 1 oscillator input. Is this clear? Identical to the timer 0.
Yes. Yes.
Okay. Now, if you want to connect a crystal to timer 1, then the crystal will be connected between the pins 14 and 15. Here you have to connect your crystal. And you have to add 2 capacitors connected to the ground. So this is crystal 1. And you have another crystal connected to the pin 13 and 14, and these are, so here you have to connect the main crystal of the PIC microcontroller. So we do this to generate exact time delay. So to generate a real-time clock, we need a crystal with a specific frequency. Okay, that's why we have another place to place an additional crystal. واضحة الفكرة؟
Yes, واضحة دكتور. بس الكريستال يعني بيعطيني more accurate than the timer 0. هاي البريفليج تبعي.
لا, it depends on the crystal that you are using. So one of the advantage of using timer 1, for example, if your application is real-time clock and you want to generate, for example, an alarm, okay? So while your PIC microcontroller is waiting for the alarm, you can make the whole PIC microcontroller in sleep mode. So only timer 1 and the oscillator 1 is working. When timer 1 generates an interrupt, it will wake up the PIC microcontroller, then you can make the task that you need. So then in sleep mode, the whole PIC microcontroller will be in sleep mode, except the timer 1 with its external crystal. Okay, so this is one of the advantages of using a second crystal.
Yes, clear inshallah.
Any other questions, Shabab? Okay, so for the recording, do you have the recording or I have to upload it somewhere?
No, we need it actually, doctor.
Okay, so I have to send the links of the recording. Yes?
Yes, if possible.
Okay, so I will send you the link, okay?
Okay.
Do you have any other question?
Thank you.
Okay, so for the project, you can start working during this holiday, okay?
Inshallah.
Yalla, thank you for attending and see you inshallah next class. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alaikum salam.